Enterprise systems are software applications that automate and integrate many of the key business processes of an organization. With some understanding of software development, you will learn about current development practices for this type of system and develop relevant skills to apply them to real-world problems. You will develop core skills in object-oriented analysis and design, allowing you to develop software that is fit for purpose, reusable, and amenable to change. This unit focuses on orderly engineering for enterprise systems. In particular, you will learn about current development practices for this type of system and develop relevant skills to apply them to real-world problems. We use the term development process to refer to the set of activities, methods, practices, and transformations used to develop a piece of software and associated products, such as project plans and design documents. The unit also introduces you to the object-oriented approach to software. In particular, it will help you understand the concept of an object and related object technology concepts, such as encapsulation and inheritance. This unit only contains a brief introduction to UML, Unified Modeling Language, a primarily diagrammatic language to express models in an object-oriented approach. Current enterprise systems are large and complex, and their construction involves many stakeholders, including customers, developers, and users. A software development process describes an approach to building, deploying, and maintaining software. The advantages of following a well-understood process are many. From a manager's viewpoint, it is crucial to have well-defined activities that make it possible to estimate when a final product will be completed and the effort required to achieve it. From a developer's viewpoint, it is important to have well-defined tasks and clear outcomes and to know which documents and artifacts should be produced by each of the activities undertaken. From a customer's viewpoint, it is fundamental to be reassured that the required product is the one being built, and that it will be delivered on time and within budget. There are some fundamental development activities that are common to most processes. These are analysis, design, implementation, and testing. In very general terms, analysis deals with understanding the problem and what is required of the system to be developed. Design and implementation builds the solution, and testing helps to verify and validate it. It deals with describing conceptually a software solution that meets the requirements of the problem. The waterfall process relies on the definition of sequential phases. Each phase starts only after the previous one has finished. It relies on the existence of a set of requirements that is defined beforehand and remains unchanged during development. It also assumes that all code is designed from scratch, making no allowance for the reuse of existing software. Because the development is carried out as a linear process, the waterfall process does not allow previous phases of the development to be repeated without repeating the whole sequence of steps. Iterative and incremental processes represent best practice that has been identified from the limitations of the waterfall process. The term iterative indicates the repetition of one or more activities. The term incremental indicates that development proceeds from an initial subset of the requirements to more and more complete subsets until the whole system is addressed. Iterative and incremental process consists of several cycles of analysis, design, implementation, and testing. Each cycle is short and provides feedback for the next cycle, in which a more refined and enhanced development is achieved. As each cycle deals with a small set of requirements, the complexity of each increment is managed. The complexity of the whole system needs to be managed by progressive integration of increments. Early feedback is obtained from a partial implementation. No software development is free from risk, and one crucial activity of development is identifying and managing it. Managing risks requires an early identification of any threats to the development or operation of a system, and then monitoring these threats during development. Risks are mainly associated with making decisions that may be wrong and with misunderstanding requirements. There are different ways of classifying risks according to different authors. The unified process has emerged as a popular iterative and incremental development process for building enterprise systems based on an object-oriented approach. It promotes a set of best practices, namely that development should be organized in short time-boxed iterations and that it should be adaptive to accommodate inevitable change. These are time boxing, which is a short fixed period of time devoted to each iteration. Adaptive means that adjustments are allowed at each iteration. The motivation for this is the recognition that requirements may change throughout development and that such changes should be dealt with rather than resisted. Dealing with high-risk issues in early iterations. Giving the user's perspective great importance in the process and involving them in the definition of requirements, evaluation, and feedback. Building a view of the system's architecture in early iterations. A unified process project is organized into 4 major phases. Inception. This is where the business case is developed together with an idea of the scope of the system and a rough estimate of the effort required. Elaboration. This is where the core of the system is developed in an iterative fashion. In this phase, all major risks are addressed and resolved. Most of the requirements are identified and dealt with, and a more realistic estimate of the effort required is made. Construction. This is where the remaining lower risk and easier elements of the system are constructed, again, in an iterative fashion. Transition. This includes beta testing and deploying the system. The figure is only illustrative of what a UP project would look like. The columns represent iterations. For each discipline, the relative effort is represented throughout the UP phases and their iterations. For instance, most of the domain modeling occurs in the early iterations of the inception and elaboration phases, while most of the implementation occurs within the construction phase.